constructive and destructive waves 2. In this topic, the following subtopics will be covered: properties of waves, constructive and destructive interference, and stationary waves. In your Form 2 syllabus, you learnt about the formation and classification of waves. In this chapter, we are going to look at the properties exhibited by waves. Such properties will include reflection, refraction, diffraction, and interference. Wave properties. The following are some of the wave properties: reflection, refraction, diffraction, and interference.
Reflection. Waves are reflected according to the same laws of light reflection. The following animations show how waves behave before and after reflection when they hit differently shaped reflectors.
Reflection of plane waves after hitting a reflector at an angle. When the plane waves meet a straight reflector at an angle, they are reflected as shown in the next animation. Play the animation to observe the behavior of the waves. Reflection of plane water waves after hitting a concave reflector. The animation below shows what happens when plane water waves meet a concave reflector. Click on the play button and make your observation. Reflection of plane water waves after hitting a convex reflector. Play the animation below and observe how plane waves are reflected on meeting a convex reflector. What do you observe? Observations. The waves appear to be diverging from a point behind the reflector, showing that the convex reflector has a virtual focus. Reflection of circular water waves after hitting a concave reflector. Play the animation below to observe how circular waves incident on a concave reflector behave on hitting the reflector. Refraction of waves. This can be demonstrated using a raised platform in water when a wave created at the deep end is observed as it moves through to the shallow end. If the depths of water are different, the direction of the wave changes. At the shallow end, the frequency of the wave remains constant. Light behaves in a similar manner when it moves from a rarer to a denser medium. For sound, refraction occurs due to the change in speed of the wave. The speed is also affected by temperature. As sound passes through layers of air at different temperatures, it is refracted to other directions. On a hot day, the range of sound is less because the waves are bent upwards from the hot earth where they otherwise travel faster. In the evening, or when cold, air near the ground becomes cool and refraction makes it easier to hear distant sounds across the land.
Diffraction. This is the spreading of waves around obstacles or as they pass through openings or gaps. Play the video below to observe this. Discussion. Diffraction of the waves is greatest when the wavelength of the waves is similar to the width of the slit or gap. For a given wavelength, the narrower the gap, the greater the bending of the waves. Sound easily spreads round corners because of its long wavelength. During diffraction, the velocity, wavelength, and frequency of the wave remain constant. Sounds of shorter wavelength are least diffracted and hence more directional. It is for this reason that high-pitched sounds are heard best in front of speakers and not behind them. Light has very short wavelength and requires a very short aperture to show significant diffraction. Radio transmission at long wave meter band can have good reception over a wide area.
Interference. This is a term given to effects of waves which occur when two or more separate wave trains overlap. There are two types of interference: constructive interference and destructive interference. Constructive and destructive interference. Constructive interference. The production of increased amplitude when two waves are in phase is called constructive interference. Play the video below to observe this. Observations. Bright and dark fringes, that is lines, are seen on the white screen. Discussion. The formation of bright and dark lines show that interference is taking place. The bright lines show the parts where the waves from the two sources interfere constructively, while the dark lines show points where destructive interference takes place. Conclusion. The production of increased amplitude when two waves meet in phase are called constructive interference, while the reduced resultant amplitude caused by the meeting of a crest and a trough is known as destructive interference.
Stationary waves. Stationary waves can be produced on a string by either plucking it or creating a vibratory motion on it. Click the play button and make your observations. Observation. A standing wave with nodes and antinodes is formed. Explanation. The particles at the fixed end cannot vibrate and therefore undergo zero displacement, forming a node. At the antinodes, the particles are free to vibrate horizontally and are therefore displaced, thereby forming an antinode.